Okay, so to all the participants of the 6th AIEE Energy Symposium on Energy Security, I extend my warmest welcome on this plenary. Is the last but not least the plenary of our very intense program on the hydrogen revolution, on hydrogen, okay? Now, the question I think is very important. We have three distinguished speakers. We have Dina Lanzi from Snam. She's the head of the Snam hydrogen unit. I shouldn't comment anymore her extensive and important curriculum because her experience in the organization of Snam has been excellent. And she's now the right person in the right place to tell us what we can do in an effective and concrete way in Italy, in Europe, in the world, for these reasons. We also know that the second speaker is Rami Shabaneh. He's a senior energy analyst of KAPSARC, the prestigious King Abdullah Petroleum Studies and Research Center in Riyadh, Saudi Arabia. This is a center that has now in the recent past become top think tank and research center in the Middle East region and in the worldwide energy field. And so I'm very proud to have Rami with us, who will also tell us, I think, the most important, not just one, but the most important view that in that part of the world can be put forth about hydrogen. Why am I saying this? Because with the carbon circular economy, His Highness the Prince Abdulaziz bin Salman, Minister of Energy, has launched in Saudi Arabia, which is the biggest producer, the most important producer of oil in the world, a revolutionary idea of using oil in the premise to do some industrial activity, that is burning it, and capture the CO2 and use that for enhanced oil recovery, so making a circular, essentially, process that is of paramount importance, because the result of that activity, I call it industrial activity on premise, rather than shipping oil that is burnt in Europe, for instance, they can produce something else that can be shipped blue, almost green, because of the sequestration aspect, okay? And the third, last but not least, speaker who will join us later is Dermo. He's from the WEC, the Secretary General of the World Energy Council, Italy. He has been there for a long time, so another authority in the energy field, okay? So I'm only a professor of economics and energy economics, so I'm eager to listen the view of the industry, of the research centers worldwide, of the international organizations, to see what we can do with hydrogen in the future. And the issue is not only industrial and economic, but it will have, not necessarily in this session, of course, because it's a delicate issue, but I prepare our listeners for the future, the next conference probably that we will hold soon, on the geopolitical implication, because electric cars, electrification, and batteries means rare minerals and manufacturing in China. Hydrogen, blue hydrogen or green hydrogen, like the one which will be produced in NEOM, with a recent agreement where Snam participated, by the way, with NEOM is the new industrial futuristic site that Saudi Arabia is constructing north of the Red Sea. That will be a different view of technology, clean, equally clean, but of a different implication for the infrastructure, for the engines, for the type of mobility that we will give to the future generation. So this was the introduction. I think for courtesy and cavalry, the best way is to give, I think, the word and the floor to our distinguished lady of the panel, that is Dr. Dina Lanzi. Please, the floor is yours.
Thank you very much. Thank you very much, Carlo, for the warm presentation you did and nice words you spent for me.
Okay, remember we have an hour, so let's say that we stay within 15 minutes so that we can exchange the last 5 minutes of each presentation among the other people. Okay, go ahead.
Yeah. I'm sharing my screen with the presentation. Okay. So I would start, as you know, I'm the first of the panel. Maybe I can start, you know, just with the first with hydrogen in a glance. So what kind of hydrogen we are talking about? Why hydrogen? What you can do with hydrogen? So the hydrogen can be produced by using the fossil fuel, and is the way that we are producing hydrogen in this moment currently. More than 90% of the hydrogen produced with methane, or anyway fossil, has fossil origins, with the steam methane reformer primarily, and it's called gray hydrogen. So it's the hydrogen that we use in the refineries, in you know, for fertilizer production, for example. If you want to decarbonize this hydrogen, you have two main ways. You can capture the CO2 from the production of hydrogen in the original way, so from fossil fuels, or you can produce entirely in a green way using renewables. So this green hydrogen is the one that is completely decarbonized. So is you know, in the production phase and in the utilization is completely green, so no emission, zero emission. Why hydrogen? Because hydrogen is, as I said, can be produced completely zero emission. It's particularly easy to transport and to store. So it's an energy vector, is an energy way. It's energy you can easily transport and storage and store, because usually molecules are easier to store and to transport if you compare to the electron. And so that's why it's so interesting for us. And it can be used and transport using the gas infrastructure. So we will be more precise on this, but this can be a very good opportunity to use existing infrastructure in all Europe. Where we see applications for hydrogen, first of all, in you know, the sector coupling. So is you know, the way to couple the electric grid with the gas grid. So if you have, for example, with a high penetration of renewables in the electric grid, you can have problems, you know, to manage and to dispatch all these energies. So you can use electrolyzers that are, you know, these appliances that can transform electric energy in hydrogen, to help, you know, the electric grid to use all the renewables that you have, the availability of all the renewables. Then you can use also hydrogen in the industrial sector. So in a very similar way you use today gray hydrogen for refineries or for fertilizer, you can substitute the gray hydrogen with green hydrogen. You finally can use it for transport, because is you know, another zero emission way to use you know, to have mobility. For example, in the heavy trucks could be a very good alternative. And finally, you can use to self-produce, for example, electricity using a fuel cell powered by hydrogen. This is a way, for example, in the United States, they are starting to fuel data centers, to produce energy for data centers in this way. So zero emission energy. Okay. These are some numbers to make easier, you know, to understand when hydrogen become competitive in comparison with other form of energy. For example, in mobility, the break-even point is about you know, less than 7 $5 per kilo. So he is maybe the first way, the first application we will see, because the economics are more positive in this field in respect with other. In particular, as I said, in trains, and we already have, for example, in Italy, an applications for an hydrogen train in the close to Brescia. We have the project of the first train, hydrogen trains. And the second one is the feedstock and industrial applications. So as I said, to feed refineries or chemical like fertilizer, green ammonia application. And here you need to have anyway a price of the hydrogen is less than $4 per kilo. And in the last part, if you arrive, beyond €2 per kilo, then you can also address industrial use, thermal industrial uses. So you can use hydrogen for thermal application, like you use now natural gas. For example, in high temperature processes like glass makers or ceramics or steel, first of all, steel, for example. What is happening is it's amazing, because there is a lot of interest of all the countries in hydrogen in Europe, but also outside Europe, as we have seen. And there is a very big cost reductions in these years. And so these curves that you see here, every year are going to change, because the shape is increasing, because there are some factors that are influencing these prices in a good way. First of all, the price of technology that is decreasing a lot, and so in these two last years we have seen a decrease of 20% of the cost of the technology, and also the cost of energy. There are some countries and some geographies where this cost of energy produced by photovoltaic or other renewables is particularly good, and so has a particular interesting price. Here you can find also, the comparison with the cost of traditional fuels, and where, the break-even is set, and when we think that could be, the here of where the competition of hydrogen is become interesting. What is doing Snam on hydrogen? We are working mainly on 3 pillars. The first one is asset readiness. Anyway, Snam, is the biggest TSO transport operator, gas transport operator in Italy. So what we are doing now is trying to make available all our assets for hydrogen. I mean, the pipelines, first of all, we have 33,000 kilometers of high pressure pipelines in Italy. But we have also the storage, for example, and we think that the underground storage is a key factor to enable the use of hydrogen, because, you can avoid the intermittence of renewables that is connected to the producing of hydrogen, of green hydrogen. So we are studying, we are assessing our pipelines, and we have seen that almost 90% of the pipelines is ready for transport 100% hydrogen, so pure hydrogen, let's say. And 70% is with no decrease of pressure. So at the same pressure we use now for the methane. And on the storage, the analyses are still ongoing. We know that we can arrive up to 2% for sure, but now we are trying to understand with Polytechnic of Turin making also some laboratory tests, but addressing also a test, an operative test in operation, to understand if we can use, these depleted fields also for storage, to store blending of hydrogen and natural gas or pure hydrogen. The other pillar is on system design, because we know that to enable the use of hydrogen in the and to enter the hydrogen, the energy mix, we need also to have and to fix the rules, because now there is a lack of rules from the technical point of view. For example, we are using American standards to assess our pipelines, and so we need European standards anyway, and we are working on this, and also on the level of hydrogen, for example, you can inject in the natural grid, because in the natural gas grid, because now we don't have this threshold in Italy, and also from the regulatory point of view, and in general on the legal point of view. So we are trying to set all these rules and to work on this system design pillar. The third one is value chain development. Here we think that Snam, that is anyway an operator of infrastructure, can play the right role to match the offer with the market. So we are working together with other potential end users, like Mobility Run, for example. The project of hydrogen train is in cooperation with Ferrovie Nord Milano and with Alstom for the train supply. And the same we are doing, with the steel makers, like, we will show a test we made in a steel making factory, and with ceramic producers, glass. So we are trying to address all the value chain and to match, as I said, the offer of hydrogen with the market. Also, thanks to our partnership, we had a partnership with the Industria Denora, that is an Italian excellence in electrodes production, mainly for alkaline electrolyzers, and with ITM Power, that is a PEM electrolyzer producer. On the readiness of the asset, the things we are doing in our country, so in our asset, in our pipelines, we want to match the activity we are doing also with the rest of Europe. So we participate to a consortium of 23 gas infrastructure companies and 21 countries in Europe, to have the first hydrogen European backbone. The idea is to have the first 6,000 kilometers before 2030, and to arrive to 40,000 kilometers in 2050. Most of this pipeline will be repurposed. So the idea is to use mainly the asset we already have for the natural gas, and 31 will be a new one, so new pipelines. The interesting, the very competitive price we have with this hydrogen backbone for transport is can enable the transport of hydrogen on very long distances, because we calculated to have a cost of hydrogen transport between 0.1 and 0.2 euros to transport 1 kilo of hydrogen for 1,000 kilometers. So it's a very competitive price. And in this way, we also think to enable the import, for example, from North Africa, where we have already the pipeline from Tunisia to Sicily. And we make a deal with Eni on this, buying these pipelines connecting, North Africa to Italy. Some examples of the project ongoing for Snam. I already talked about the project we have, the test we have with the RINA and the group GIVA, where we arrive at a blending of 30%, and we use this in a forging process. And this project was very interesting because no kind of modification were made to the process of the forging process. So they use these 30% blended hydrogen and natural gas using the same appliances that they use for natural gas. We are also doing a project with Bormioli for the glass production. The idea is the same, to understand what is the threshold that this kind of appliances can use with no kind of modification, because this is very important to understand what kind of of level of hydrogen we can reach with no big investment from the end user side. And then also, for sure, we are working also on new burners, for example, 100% hydrogen in collaboration with other players. For example, Tenova is developing these kind of burners 100% hydrogen. We already talked about this hydrogen train from Brescia, Iseo, Edolo in the north of Italy. And we will have, 14 trains supplied by Alstom by 2024. We work also on in steel sector with Tenaris to produce green hydrogen in Tenaris mill, and this project has been addressed also in IPCI projects, so the important project for European interest. And the last one is in Ceramica with the Iris Ceramica Group in tiles sector, to have also here the green product, so the new green tiles. Okay. I think that I was in time, and I'm available.
Thank you very much, Dr. Lanzi. With no other delay, I immediately give the floor to Rami Shabaneh of KAPSARC. Please, Rami. There should be a change of, I think, sharing the screen, please.
Yeah, sorry. Okay.
Okay. Can you see my screen in full screen mode? Is that fine? Yeah. Okay, thank you, Dr. Bollino and the AIEE for inviting me and sharing some of the insights here from Saudi Arabia. I'm glad to be here also with the esteemed colleagues and panelists. So I'm just going to give a kind of, from a perspective of hydrogen from Saudi Arabia. There has been a lot of momentum in the last 24 months when it comes to hydrogen initiatives in the kingdom. And I think the energy minister has recently announced that they have this ambition of producing 4 million tons of hydrogen, carbon neutral hydrogen by 2030. So there's a big drive to go that way, and being part of the solution for the energy transition, really, both in Saudi Arabia and globally. So Saudi Arabia really started its hydrogen journey with a bang last year with 2 milestone announcements. The first one coming from NEOM in the left-hand side of the map. This is a joint venture between NEOM Air Products and Aqua Power, where they will use 4 gigawatts of renewable electricity to produce about 650 tons a day of hydrogen in the west coast of Saudi Arabia. All of that will be turned into ammonia, and almost all of it will be earmarked for exports. And it's slated to start in 2025. In the right-hand side, Aramco and SABIC, along with IEEJ, also demonstrated a first of its kind, really, blue ammonia shipment from the east coast of Saudi Arabia. This was a 40-ton shipment. It was done one time just to test the supply chains, if it works, you know, tying in a few ammonia plants with the gas plant over there, or the CCS plant, and shipping it and seeing how it all works. And hopefully it will turn into a commercial production soon. So along with testing both pilots and demonstration projects, Aramco has, or Saudi Arabia, I should say, has been very active in collaborating with international partners. The recent ones with Germany, as well as Aramco with Hyundai Heavy Industries. So really, like I mentioned, there's been a lot of momentum, and Saudi Arabia seems to be very serious when it comes to hydrogen production and exports. Now, from a resource perspective, theoretically speaking, Saudi Arabia could produce only blue hydrogen. Like, it could have a strategy of solely producing blue hydrogen or solely producing green hydrogen. But it's important to remember that Saudi Arabia is a large country, the largest country in Western Asia, and its resources is not distributed equally across its landmass. So from a cost perspective, you know, a low-cost solution can be met by developing both pathways simultaneously. So if you look on the right-hand side of the map, this is where all your oil and gas cluster is grouped. And this is obviously where the blue ammonia shipment was made, because, you know, everything, all the industrial ports, the industrial plants where ammonia is made, majority of it is in the East Coast. Majority of your CCS or storage sites for CO2 sequestration is also there, where the oil and gas fields are. And so it makes sense to produce it over there. At the same time, transporting gas to the western side, you can see there's not much pipelines going from the east to the west. There's only that one pipeline. But if you want to go to the northwest, for example, where the NEOM project is, you know, it's very hard to deliver gas there. And the delivery cost also could be expensive. And by comparison, the western side is much, much better when it comes to solar and wind resources than it is in the eastern side. And so they really complement each other. And that falls well with the circular carbon economy framework, which is very technology agnostic. It basically says, you know, it's whatever, you can go with any technology if it's deemed economic. And that is the approach that Saudi Arabia is taking. Here, I want to zero in on the cost of renewable electricity in Saudi Arabia and the cost of gas. So the chart on the left shows the PPA prices that were signed since 2018. 2018 was when the first solar or utility scale solar plant was auctioned. And the bid came at about $23 per megawatt hour. That was in 2018. A year later, there was a wind project that came around the same price, around $20 per megawatt hour. But the recent one in 2020, 2021, we've seen that these PPA prices have dramatically fallen. On average, this year, the PPA prices have been around $18 per megawatt hour, but with the lowest price being at around $10 per megawatt hour, or 10.4, which is the Shuaiba PV plant in the western coast of Saudi Arabia. So that's really impressive. I mean, we were testing, you know, that $15 per megawatt threshold, and now we're really testing that $10 per megawatt threshold. So that's very promising, and that this is the new record. And I think Dr. Dina showed that in her graph. On the gas side, yes, Saudi Arabia has a vast amount of natural gas reserves. I think it's ranked 5th or 6th in the world right now after the latest audit. It's important to note, though, that majority of the gas, majority of the component of the gas comes from associated fields. But in the future, a lot of the developments will be in non-associated gas, so the cost will go up. So with blue hydrogen, it's really contingent on the price of gas. But right now, domestic price of gas is really low, and there's a lot of cushion there for Saudi Arabia to produce blue hydrogen competitively. So what does that mean for hydrogen cost? Well, at KAPSARC, we ran some numbers. We ran them for 3 colors, the gray, blue, and green. Even we tested the grid electricity or gray electrolysis, grid-based hydrogen, which is the most expensive option given the high industrial tariff currently. Of course, a gray hydrogen from an SMR is the cheapest option. So the domestic price currently in Saudi Arabia is about $1.25 per MMBTU. So that gives you a hydrogen price of about, a gray hydrogen price of about 90 cents or just under $1 per kilogram. So for blue, obviously, it's more competitive than green. It comes at about $1.34 per kilogram at that same price. But as you can see, we've tested different scenarios. Given if there's going to be some price reforms happening in domestically here, it will change the price of the blue hydrogen. Of course, green is more expensive than blue today in Saudi Arabia. But like I said, and I'll show you in a later slide that the cost declines there. So currently, if you take the $18 per megawatt hour average price here in the kingdom, that comes to about just over $2 per kilogram. But that's still more competitive than, for example, in Europe, and more competitive than places in the United States. So 2030, if we look at the outlook, how do we see the cost coming down? So let's start with blue hydrogen. So blue hydrogen, really the major cost decline will come from the capex of the CCUS plant. There's about 30% reduction in 20% reduction in the CCS capex. So that will help. And if you stick with the natural gas price of $1.25, you could go down to $1.13. However, in the long term, as I mentioned, Saudi Arabia is developing non-associated natural gas. So we expect that the price of natural gas will go up. And if you see on the chart on the right, blue hydrogen, as I mentioned, the natural gas is the most sensitive component when it comes to the cost. So if you shift the cost, just $1 higher, you'll see a significant jump in the cost of natural gas. So that's important to keep in mind. In terms of green hydrogen, the rate of decline is expected to be more than blue. We expect to see a fall from the over $2 per kilogram today to just under $1.50. And that's mainly coming from the drop in renewable energy prices. Like I said, if the $10 per megawatt hour example that one of the PV plants, PPA plants, was realized more and more, you could really get to that dollar, even $1 per kilogram. That's if you see also the capex of electrolyzers come down. So it's really could be very competitive globally from Saudi Arabia in the long run. And of course, the capacity factor is also important. I have to make a note of that. In NEOM, they are using a PV wind hybrid. That's because you don't have to only depend on the solar, but also the wind during the night. And there they have really thermal winds, really good wind conditions in NEOM. So in one of their presentations, they've said that they could reach capacity factors of 50, even 60%. That's almost like a combined cycle plant for natural gas. So they can get really high capacity factors with the hybrid model, PV and wind. And I think future projects of green electricity in Saudi Arabia are going to follow that as well, the hybrid model. So to sum up, really to summarize the cost of the technology both in 2020 and 2030, you can see that the drop in green hydrogen sees the biggest drop. However, blue hydrogen remains competitive by 2030 if price of gas remains constant. But we estimate that if the price goes to $3 per 25, you could break even with renewable electricity. So that the domestic price of gas goes to $3 per $25 per MMBTU or higher. Green hydrogen will be more competitive. So what does that mean when it comes to the export market? Well, the chart on the right estimates that the delivered cost of green hydrogen from, say, the northwest region of Saudi Arabia, where that NEOM is, to Rotterdam by the different carriers. You can see that it could land there quite competitively. I mean, it depends on where the price of hydrogen in Europe is by then. There's an estimate that, you know, the Southern Europe could probably produce hydrogen as low as $2.5 to $3 per kilogram, whereas Northern Europe could produce it at around $5 per kilogram. So it really falls within that band, really. But this is important thing to note that majority of the hydrogen will be transported using ammonia, because this is the easiest and more commercial way to transport ammonia currently. This is, I'm talking about deep sea shipping. And you could tell that yellow segment of the chart in the last for the ammonia or the LOHC. There's a significant cost of decomposing ammonia back to hydrogen if you want to use hydrogen as a pure use. So that's something to keep in mind, and probably in the long run, you know, that we really need to scale up liquefied hydrogen production so that it removes that cost of conversion. But currently we're not there yet, but that's something to think about.
Okay.
So here, it's just a thought experiment that we wanted to do to see, well, you know, if Saudi Arabia uses 5% or 2% of hydrogen domestically, you know, how much hydrogen demand would that entail? And then how much resources will it pull if you use green only or blue only? And so if you look at the 5% penetration of hydrogen in the final energy demand by 2030, that's estimated to be about 2 million tons of hydrogen per year of use. And that will take, you know, a lot of renewable energy to create. We estimate it's going to take about 44 gigawatts of renewable electricity just to, you know, insert about 5% of your energy demand from hydrogen. So that could, you know, have a lot of stress on your resources, on your land, on the cost. And that's why we always promote both blue and green hydrogen can complement each other as opposed to just focusing on one technology or, you know, promoting one technology. So to conclude, you know, like I said, with the abundant renewable energy potential, significant resources, you know, Saudi is well placed to be most competitive, you know, a hub for production and for exports. You know, that's, like I mentioned in the earlier graph, you know, it's important to take the distribution of resources into the equation. You know, not just focusing on solar or natural gas. You know, depends on where they're located in your country. It could make them the optimal solution could be developing both. Blue hydrogen, of course, currently has a head start over green hydrogen, but you know, further declines in capex are expected with scale up, and it's important to also understand that they are sensitive to natural gas prices. Green hydrogen, we estimate that it's likely to reach $1.50 by 2030, and even lower if the capex, especially if the capex of electrolyzers go lower than we estimate. For the $1.50, we estimated $650 per kilowatt electrolyzer. If you go down to that $400 range, you can get to that $1 per kilogram. Yeah, I'll end it here, and I'll pass it back to you, Dr. Bollino.
Thank you very much, Rami. And last but not least, we have Paolo Derma, who joined us a few minutes later, but he has listened to all the presentations. So I give you, the floor to you for another 15 minutes, so we can have the last 5 minutes for some round conversation. I immediately pose 2 questions for the future, Paolo, you and the others. $3 to $5 per kilogram, is this a realistic view from the European, from the Saudi viewpoint? And the second question is more strategic. Blue hydrogen and green hydrogen, Rami said, are complements. For us Europeans, the first is the transition to the second. So you have all complex dynamic strategic planning and project to handle, to make blue hydrogen immediately capable of making acceptance of this technology in view of the green that will be gradually substituting the blue in order to achieve full carbonization. So there is a dynamic, substitution issue as well. Paolo, the floor is yours.
I'm sharing the presentation. Thank you, Professor Bollino. I would like to share with you 2 exercises that the World Energy Council ran in 2021 about hydrogen. Our perspectives on the global energy strategies in hydrogen, the first one, and the second point will be a focus on the European Union. In particular, the World Energy Council Europe collaborated with the Observatoire Méditerranée de l'Energia in running several scenarios for potential demand of hydrogen in the European Union to 2050, and the need for import from outside Europe of hydrogen. So something that also our gas operator is studying very well, as we see in the previous slides from Ms. Lanzi. The first exercise that we ran in 2021 at global level was an interview, a survey with high-level representatives from government, energy companies, and also academia, civil society about what are the main issues and topics that the world of energy is debating, because within the World Energy Council, we are in almost 80 countries with different stakeholders, from institutions to also civil societies and energy companies and so on. So I give you, I put in presentation. Okay, can you see the slides?
Yes.
The first issues that was on which there is a wide agreement is that the confusion about color is mounting, because there are a lot of different strategies at national level in different parts of the world, and each one of these is choosing a color. It would be better to choose a clear indicator of what would be and what should be the hydrogen in the future, and this one could be, for example, decarbonized hydrogen. So we have to think about how to decarbonize the hydrogen driver, more than discuss about colors. Another important topic that we also have encountered in many countries is the need to focus on uses more than the way of production about energy, hydrogen, excuse me. And so on this point, we would say that in Italy, for example, there are important projects, pilot projects, that are focusing on the use of hydrogen, not only on the production. So we see that in Italy, for example, we are going through these issues to focus not only on the production side, but also on who will be the most suitable user of hydrogen in the next year. Another very important point that we have discussed with the international stakeholders is the repurposing not only of the infrastructures, but the repurposing of skill and the repurposing of skill inside and within the natural gas sector. This is a very important issue, and in different countries they have highlighted that there is a short-term issue. Because, for example, in order to advance in including blending hydrogen inside the existing natural gas network, there are important competencies that can be upgraded and developed from the natural gas sector to the hydrogen sector. Last last slide of this first part of the presentation, we have also surveyed different focuses in different regions about the energy strategies. For example, in Asia, if we look at South Korea and Japan, they are targeting more the power sector and transport sector. For example, in Japan, there is an important development in the fleet truck owners association that is running a new strategy to decarbonize the heavy duty transports, and they are looking at gases in general and also LNG and hydrogen and so on. And we also see that in other parts of the world, for example, in Europe, we have different sensitivities. For example, Spain and Portugal are thinking about hydrogen also as an exporter. We have a strong focus stronger focus in the European Union about projects for industry, but also transport is targeted for sure. And again, in Italy, we have examples that we have listed before in first applications or first pilot projects in the industry, heavy industry. In North America, we have also an attention to the blending of hydrogen with the natural gas. So we have different approaches in different parts of the world, and these tell us that as the energy transition, also the hydrogen transition will not be the same in any region, will not be the same in any country. And we also saw the presentation from Saudi Arabia that has a very different approach from the several approaches that we have in Europe. So this is very important to have this view. And together with PricewaterhouseCoopers, we also run a possible evolution of energy demand at global level at 2050. As you can see, there is a wide range of opportunities and wide range of alternatives in terms of the potential demand, and it will depend a lot on what will be the scenarios that policymakers and also institutions will succeed to put in place. I mean, a regulatory framework that is consistent with 1.8 or 2.3. 2.3 degrees. So one message that I want to leave you with this slide is that in any case, after 2025 and 2030, we expect at global level a faster increase of the demand in hydrogen. So this is what this slide tells us. What about the second part of this presentation? What about Europe, the European Union? This study, the study that we run with the AIEE, is the first of a kind because we not only deepened the issue of how much hydrogen Europe will need inside Europe, but also how much import Europe will need by 2050 if want to produce and also use that quantities of hydrogen. So we know that in the European Union there is a very important regulatory revision that is the third package, gas package, and we have also read that in these days that the third package is moving forward forward with the integration of gas system, electricity system, and also hydrogen system. So this is a good evolution. And we started from that regulatory framework, assessing also what is the situation today about the hydrogen demand in Europe. What are the main countries that are consuming hydrogen, are utilizing hydrogen today? And as you can see, that is between the biggest consumer in Europe of hydrogen. Germany and Netherlands are at first place. And obviously, this consumption of hydrogen is very linked to the heavy industry. So we know why this share is it appears. What about the objectives that the same countries set for 2030 in terms of production of hydrogen by electrolyzer, from electrolyzer? I mean green hydrogen from electrolysis. Italy and Germany, again, are between the countries that have set the biggest target to 2030. You can find in this chart what are the gigawatts that are expected to enter in operation by 2030. But at the same time, if we look at this second chart, we see also that in any case, by after 2030 and by 2050, Germany and Italy that are among the countries that are moving forward will also see a very important part of import of hydrogen from outside the country. In general, the European Union is expected, basing on our projections, is expected to import almost the half of the hydrogen that the half of the decarbonized hydrogen that need in 2050. And this leads to a very important issue that we also quantified in this slide, the issue of how much capacity has to be installed as renewable energies in order to supply green hydrogen, so hydrogen from electrolysis, in addition to the other quantities of hydrogen that will be imported, for example, from steam reforming plus CCUS, as we said before. And this chart tells us that there is a huge challenge about additional capacity to be installed in Europe. We know that only the objectives that we have to 2030 and 2050 about renewable energies are very challenging. So we have to add the challenge, another challenge, that is the additional installation of renewable energies. This for the green hydrogen from electrolysis. So it is very important. I share the point of view of Rami. It is very important that we consider an approach on decarbonized hydrogen without picking today specific technologies, but going forward to consider all the kind of technologies that can decarbonize more and more hydrogen within 2050. This is a chart on the cost of hydrogen, and the range that you see here is more or less the range that Professor Bollino first said. Between we arrive at 5 in your range of $35 per kilogram. This is a projection of what would be the cost of important hydrogen, decarbonized hydrogen to Europe in 2050. This slide is obviously an evolution of what will be also the decreasing of the cost of the technologies about hydrogen. So we could have a better scenario. You see that there is a range also when we look at shipping, liquefaction, transmission, distribution. There is a range that we have considered, considering that the evolution of learning curve of technologies will help to decrease this cost. Saying that, there is an important work to do about the decrease of the cost of the transport, for example, liquefaction, shipping, transmission, distribution. But on the transmission and distribution, we already are seeing a very important developments starting from Italy, for example. We have heard before about the provisions for Snam. This slide tells us what would be the hydrogen demand, potential hydrogen demand in these scenarios in Europe, and also the kind of hydrogen that could afford the demand that we see in 2050. As you can see, the imported green hydrogen from electrolysis will be the biggest share, but it's not enough alone. So there is also a part of imported hydrogen from, for example, blue hydrogen, the one that we heard before. And there is also a need of investments that is important at annual rate in order to repurpose or modifying or developing also new infrastructures for the import of hydrogen from outside Europe. And we are more or less in this range. We have also focused on specific European countries with this study, for example, on Italy. And I have reported the chart of Italy and also highlighted the numbers of potential, not potential, but the numbers of additional capacity needed to arrive to the scenario that we saw before at the European level, and what will be in 2050 the additional capacity in terms of gigawatt in Italy needed for wind onshore and also photovoltaic in order to produce the hydrogen we need. And also in this scenario in which we would have more or less 30%, 27% increase in photovoltaic capacity and 76% capacity in wind onshore, we have also to import several quantities of hydrogen. So coming to the conclusion of our analysis, and obviously I'm available for sharing with you also the entire study, the entire analysis. If you want, I can share with colleagues the entire analysis. But coming to the conclusion, we learned that, and we are also agreed as a World Energy Council Europe that the hydrogen strategy has to be included in a wide energy strategy. That is the approach that the European Union is following, because as I presented before to you, the European Union with the third package on natural gas is moving toward the integration of different energy systems, natural gas, hydrogen, and electricity. In addition, in any scenario, the production of hydrogen in the European Union will be not enough to address the demand that we are thinking about for moving forward in the decarbonization of our energy system. So there is a very important point that that we are addressing as Italy with Snam, but also at European level with other gas operators are addressing, that is the repurposing of infrastructures, but also the development of infrastructures for allowing to import several quantities, significant quantities of hydrogen to Europe. And there is also an important theme of investments in this scenario, or the number that you see here is the number of that would have the number of the investments, 760 billion euro to 2050, that would allow the import of more or less half of the hydrogen that the European Union will need in 2050. So an important amount, and without the implementation of a clear regulatory framework, and also with national policies, clear national policies, will be very difficult to attract this kind of investment. So these are the main topics, and I would prefer to stop here and listen if there are some interactions.
Okay, thank you very much. We had a very dense session. We are almost at the end. I ask Anka and Regia of AIEE if there are questions from the floor. In the meantime, I have a reflection. I mean, I have a thinking. Rami said that there is a cost of, you know, when you ship ammonia, you have a cost of course, rehydrogenation. However, from a European perspective, where we have a lot of agriculture, I think that the N part of NH3 can be used for a benefit, not for a cost, as a fertilizer, no? Because you can make, of course, you know, azoto, you can use it as a fertilizer for agriculture. So I wonder if your cost includes the additional benefit of reusing that for agricultural purposes, recycling the part of N that you take out of NH3. And I also would like to ask Dina Lanzi if she agrees with the, the 3 to 5 threshold, floor and ceiling that was presented, and what Paolo Dermo thinks about, these $5 per kilogram ceiling, if that is a realistic, cost and learning by doing, even considering that we have to import 50% of it, as Paolo Dermo said. I leave you all the floor for the last intervention. Please go ahead, all of you.
Yes, thanks for the question, Dr. Bollino. So if you're importing as ammonia, this is already a fertilizer, or you can use it to make fertilizer. You don't need to decompose the ammonia and get the N and then combine it again with hydrogen to make fertilizers. It's already in the form of ammonia, which is the base to make nitrogen-based fertilizer. Yes, that could displace gray ammonia in Europe. If this is what, if it can do that, it can do that. Actually, I am I do support the idea that hydrogen, it's much easier to make end products with hydrogen, such as green steel, green ammonia, green cement, and exporting that as bulk products is easier to export than it is to export the raw material.
Okay.
And then making the end product at the delivered region or country. So I think that serves two purposes. First, from Saudi Arabia's perspective, it could decarbonize existing infrastructure like the ammonia, steel, cement. At the same time, you're also exporting competitive, green finished products.
Thank you very much. Dina Lanzi, what do you think about this cost? And 50% imported means that we need 50% of infrastructure to bring it back to Europe, right? From Snam.
Yeah. I think, yes, we consider import a very important to have a very important role in the future, also because we know that anyway in Italy, as we need, as Paolo was showing, we need a lot more renewables to produce, and we need renewables to fulfill to arrive to the targets for renewables that are used directly as as they are, and plus we have additional power for the hydrogen. So for sure we think that we need to consider the import of hydrogen for Italy and also for Europe in general, and here Italy can play a very crucial role as a hydrogen hub because of the possibility to use, for example, the connection with North Africa. But we are also very interested the activity that Saudi Arabia is doing on this, because we think that it's very relevant. Anyway, in the analysis, just a few comments. It depends a lot on for sure, because here is the preview to 2050, so it's a very long idea. First of all, maybe the production, we are a little bit more optimistic because we think that in particular in for example, North Africa, the cost could be lower to produce green hydrogen there, with very similar, to the numbers that Rami have shown, and plus for sure the transport. But here, if I understood well, we talk about liquefaction and shipping. So we chose a particular way to transport, that is the liquefaction. We know that liquefaction is very costly, and you need to have a huge plans to try to decrease the cost of these kind of transport. It's true that we are talking about 2050, and so maybe there are some possibility to decrease also these costs for the maturity of the technology. Anyway, as I said, we with a pipeline, if you can reuse the pipeline, if you have, for example, for us, for Italy, and for Spain, for example, from Africa, could be a very competitive cost. You need to retrofit for sure the transport, in particular for the compressor stations, that you need to change completely. But we think that with all the investment we calculate for Europe, as I said, we arrive to have 0.1, 0.2 euros per kilogram of hydrogen transported on 1,000
okay, good. A last provocative question for Paolo Dermo. He has interviewed, respectful, experts and other important people around Europe or around the world. Now, you have spoken about the need for a clear regulatory framework. Okay, now this is a period in which Europe sometimes, the regulation is, how can I say, some fantasy sometimes. What is your assessment on a scale of 0 to 10 that the European regulation will be, up to the point? 10, 9, what grade will you give right now to the Europe? Yeah, just to have your provocative answer.
I'm not a professor, so I'm in difficulties about to give votes. I'm in difficulties in comparison with you, but I would say that we have also talked with the regulatory authorities at the international level, and from the other side of the Atlantic, they see our regulation as an example to follow, because they have several problems, for example, in electricity grids, quality, and so on. As we can see, and as far as we know about the third package, I think that there are clear signals from the European Union to want to include from now on the hydrogen in the regulation about gases in general. So I would say, I don't know the number, the vote, but
but it's pass. At least it's pass and not fail. Okay, it's pass and not fail.
In the right direction.
Very good, very good. Because the European Union sometimes with the Nutri-Score, for instance, is doing something that is absolutely, stupid, with all due respect. So,
I can add one issue that Fatih Birol told through Italy in the last meeting with DNI in Italy last week. Fatih launched a warning about Europe to not do again the same thing that we have done with incentives about renewables, in which we were the first as incentives, but in the world, I mean, but the industrial chain has not followed this trend. So there is to be a very high attention from all the stakeholders, from institutions to industry, to collaborate in order to advance on innovative technologies in hydrogen along all the chain, not only the production, but also, for example, Snam with the transmission, technology for transmission and so on, and also uses like Iveco that is also launching a truck running already on hydrogen. So this is a very important part of the challenge, the industrial one, that we have not, that we have lost on the renewables, innovative renewables.
So we learn from the mistakes of the past, and we give to our international, outside Europe, to the rest of the world, the message that we are doing something that will be, as you say, a good example, an excellent benchmark for the rest of the world. That would be the message for Europe. So I thank you, all of you. I thank Anka and the Secretariat of AIEE for having us permitted to have this very interesting session. This will be is being recorded, so I hope it will go online and on YouTube, so that a lot of people will see not only today but in the future. I thank again Dina Lanzi. I thank Rami Shabaneh. I thank Paolo Dermo and the entire staff of AIEE for this session. And I think that if Anka agrees, we can conclude this session.
Grazie.
Grazie. Shukran, Rami. Thank you. Bye bye. To everyone. Thank you.
Grazie mille. Arrivederci.
Thank you very much. Thank you very much, Dr. Bollino. Thanks to all. Thank you.
Arrivederci.